All right, we're going to jump into lesson 24.3, which is properties of rectangles and squares. We're also going to take a look at some properties of rhombus as well. And I like to start with this visual representation here, and it's because it kind of gives us an umbrella effect of these quadrilaterals and the different types of quadrilaterals that we're going to look at here. So first, a quadrilateral, 4 sides. We talked about that in last lesson. Okay, polygon with 4 sides. And then specifically, we looked at parallelograms, which is a type of quadrilateral. Remember, it had some properties that we discussed. The opposite sides are parallel, opposite sides are congruent, and the diagonals bisect each other. Those are parallelograms. But then we've got some more specific types of parallelograms, and that's going to be the rectangle, the rhombus, and eventually we'll get to the square. And these types of parallelograms, they share all the properties of a parallelogram because they are parallelograms, but they also have some more requirements to be called a rectangle or a rhombus or a square. So we'll take a look at what those are right here. So first, I'll jot down a rectangle so that we can look at it visually. All right, so we got our rectangle there. It says if a quadrilateral is a rectangle, then it's a parallelogram. That means that the opposite sides are parallel. And that means the opposite sides are congruent, and that means the diagonals bisect each other. But then a couple other properties here for a rectangle. We know that we need to have 90-degree angles here, so 4 90-degree angles. And then it also tells me down here that the diagonals are congruent. So the diagonals are the same length. So not only do they cut each other in half, but for a rectangle specifically, they are also congruent. So if I draw my diagonals here, okay, we know that those 2 green lines, those 2 diagonals would be congruent, and they would also be cutting each other in half, just like a parallelogram. But for rectangles, the diagonals are congruent. Okay. And before we move on to examine the rectangles a little bit more, I wanted to just remind you of the Pythagorean theorem. Maybe you've seen this before, maybe you haven't. If not, here it is, and it tells me that if I have a right triangle, this is for right triangles. Okay. And I'm just going to briefly review this because you've probably seen this before. If I have a right triangle, okay, then I can use this Pythagorean theorem, which says that if I square the sides, so a squared plus b squared, square the legs, then that's going to equal the hypotenuse squared. Excuse me, let me get rid of these. So a squared plus b squared equals c squared is going to be my Pythagorean theorem, and that's going to come into play for me in this next problem here. A squared plus b squared equals c squared here. All right, and that'll help us find the lengths, the side lengths of a right triangle there. Notice that c is always going to be the hypotenuse. C is the longest side, which is opposite the right angle. Okay. So here we go. It says find each measure given the rectangle below. So they've told us that this is a rectangle. So we know that it has those properties that we just discussed. It says AD is 7.5. So I'm going to go ahead and jot that down. A to D is 7.5. And then D to C is 10. And they want me to find DB. So DB is this diagonal here. And the nice part about this is since it's a rectangle, we know that DB, that blue line there, that diagonal, is going to be the same as this diagonal A to C because diagonals are congruent. So if I can find A to C, then I'll be able to say, okay, well, that's the same as DB because it's a rectangle, and then I'm done. So I'm going to just make that note here that AC actually equals or is congruent to DB. So what I'm going to do is I'm going to find AC, because I think it's going to be a little bit easier, and then I'm going to know that that's going to be the same thing as DB. And the reason that's a little bit easier, because notice that AC is actually the hypotenuse of this right triangle right here. And so I can use Pythagorean theorem to help me with that. So I'm going to say, all right, well, this side length here, 7.5, we can call that A. So I'm going to say A squared, which is 7.5 squared, plus b squared, which is 10 squared, equals a to c squared, right? I'm not sure we don't know what that is, so I'm just going to call it c squared at this point, right? That's from a to c. That's the hypotenuse there. All right, and then I'm going to go ahead and evaluate this here. And so 7.5 squared gives me 56.25 plus 100 equals c squared. And then that's going to give me 156.25 equals c squared. And then maybe you remember from a couple lessons ago, to get c by itself here, in this case, to get rid of that square, we have to use a square root. And I'm going to do that to both sides. So the square root cancels out the square, and we're left with c equals, well, the square root of 156.25 is 12.5. And so that would be the length of this diagonal here, 12.5. And since it's a rectangle, if AC equals 12.5, that means that DB also equals 12.5 because AC equals DB, and they both equal 12.5, right? So if I find one diagonal, then I've found both diagonals because they're the same for these rectangles. All right, we'll keep going here. Same idea. They're telling me that AB is 17. Okay. And then they're also saying that BC is 12.75. And they want me to find D to B. So D to B is this diagonal here, right? But remember, D to B is going to be the same thing as from A to C because the diagonals are congruent. And that means I can use this right triangle here, okay? And I can set up this equation that looks like 17 squared. That's my A squared plus 12.75 squared equals A to C squared, right? I'm going to call that C squared. So we have A squared plus B squared equals C squared. And then we can go ahead and evaluate this one here. So 17 squared is going to give me 289 plus 12.75 squared gives me 162. 162.562, so I'm going to say 5.6, and that equals c squared. All right, and then I can add those things up, so I'm going to add them up. Okay, so I end up with 451.56 equals c squared, right? And so remember, to get rid of the square, I got to use the square root, so I'm going to do that to both sides. And I'm going to get 21.25 here. Is C, and remember C was the length of that hypotenuse here, so we found this to be 21.25. Okay, and so say if we found AC, we know that AC equals DB because the diagonals are congruent, and we found that to be 21.25. All right. So there's properties of our rectangles. Let's take a look at a rhombus. I'm going to go back to the diagram we had at the start. Remember, a rhombus is also a type of parallelogram. So all those parallelogram properties, they still hold for my rhombus. Okay, except rhombus has another couple of requirements to make it a rhombus. We'll go ahead and draw it here so that we've got a visualization. Okay, so we've got a rhombus there. It says if a quadrilateral is a rhombus, then it's a parallelogram. If a parallelogram is a rhombus, then its diagonals are perpendicular. Remember, we talked about perpendicular the other day. Perpendicular means that they create a 90-degree angle. So they create a 90-degree angle there. That's perpendicular. And it's telling me that my diagonals are perpendicular. So I'm going to go ahead and draw that so we can see it. Okay, so that means the diagonals are creating a 90-degree angle. So each one of those angles inside there is 90 degrees. And then it says if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. So that means it's cutting in half these angles here, right? So that means that this side is congruent to this side, and that's the same for all of these. So this side is congruent to this side, right? And so on and so on and so on. And then the last piece that's not listed here, but that's true for my rhombus, is that all sides for rhombus are congruent. All four sides are congruent. Notice there's nothing about them being 90-degree angles over in the corners here. So it doesn't say my vertices are 90 degrees, right? That doesn't have to be the case, but we do need to have four congruent sides. So that's a lot of information, right? You can pause that, kind of take that in for a second. I know that's a lot of stuff there. And now let's take a look at this example. It says find each measure given the rhombus below. So we know it's a rhombus, so all those properties are in play here. It says find xy. So xy is down here. Okay, and we know that xy is going to be the same as vw, and we also know that it's going to be the same as wx. Okay, and as vy, right? Because all of these sides are the same. Each one of these is the same. So if I can find one side length, then I've found all of them, including xy, which is what I'm looking for, right? And so I'm going to set up an equation that says 6m minus 12, right? That's the top side there. That equals the side over here, which is 4m plus 4. Because all side lengths are the same here for this rhombus. And so then I'm going to go ahead and subtract 4m. I get 2m minus 12 equals 4. Add 12 to the other side, so 2m equals 16. And that means m equals 8. All right, and then I got to go ahead and punch that back in to one of those side lengths. Okay, I can punch it into any of the side lengths, right? Because we know that if I found one, then I found them all. So I'm going to take that 8, I'm going to punch it into 4m plus 4. Okay, so I'm going to say, okay, well, xy, which is what I'm looking for, equals 4m, which is 8 plus 4. And that's going to give me a grand total of 36. Right? And that's because if I find one side length, then I found all of them because they are all congruent for my rhombus. All right, we'll go to the next one here. Got the same image. This time they want me to find a measure of angle YVW. YVW. So they want this angle here. All right, and so what we can do here is we know that YVW, it's got part of it is this angle here. So only half of it is 9n plus 4. We know that this other half is going to be the same because we know that each half of those is equal, right? Because the diagonals bisect those angles there. But that still doesn't really help us solve for this n. What I can say, though, is that, remember we talked about this, all the angles in the middle here are 90 degrees each. So if they're telling me that one of them is 3n squared minus 0.75, well, I know that that angle has got to be 90 degrees because all those angles in there are each 90 degrees. So I'm going to set up 3n squared minus 0.75 equals 90, because I know each one of those in there is 90 degrees. That's a property of the rhombus. Okay? And why that helps me is because now I'm going to go ahead and solve for n, and then I'll go and find YVW. So I'm going to add 0.75, so I get 3n squared equals 90.75. Okay, and then I'll go ahead and divide by 3, so I get n squared equals, let's see, that's going to give me 30.25. And then again, to get rid of the squared, we're going to do the square root. And so I end up with n equals, let's see, square root of 30.25 gives me 5.5 for n. So I had to find n first, and now I can go back and find the measure of those other angles because I know what n is. All right. So So we'll go ahead and work on that. Okay, so I know that this angle that I'm looking for, YVW, it's going to be 9n plus 4, and another, this one also has to be 9n plus 4, because each one of those pieces, each one of those halves of that angle are the same for the rhombus. Okay, and so I'm going to say that angle YVW equals 2 times 9n plus 4, right? 2 of those angles, right? Because it's the same for both sides. And I'm going to plug in what I found for n. So I'm going to say 2 is going to be 9 times 5.5 plus 4. So let's see, 9 times 5.5 is going to give me 2 times, let's see, 49.5 plus 4. And when I evaluate this all the way out, I get an even 107 degrees. Okay. So one more time, I just want to kind of refresh on what we just said. First, we found what n was, because we know that this angle in here is 90 degrees. That's a property of our rhombus, is that the angles created by the diagonals are 90 degrees. So we set that equation up, found n. Then I know that each one of these angles here, so like this piece and this piece, those are equal to each other, right? So if I'm looking for the whole thing, YVW, well, I know that's going to be 9n plus 4 and another 9n plus 4, because it's 2 angles there, right, that are the same. So that's why I used 2 times 9n plus 4. All right, let's finish up with a square here. It says a square is a quadrilateral with 4 right angles and 4 congruent sides. A square is a rectangle. A square is a rhombus. So if I flip back to my original diagram here, we can see that a square is the most specific type of all of these, right? It has the most requirements to make it a square. Okay, it's a rectangle, it's a rhombus, it's a parallelogram, it's a quadrilateral. And so it holds all of those properties there. So if I sketch out a rectangle here, a square here, then we know that it holds all the properties of the other pieces that we just talked about. All the sides are the same, just like the rhombus. So 4 congruent sides. It's got four right angles, just like the rectangle. And then all the properties about the diagonals also are true, okay, which means that the diagonals are congruent. The diagonals bisect each other and create a 90-degree angle in there, because a square is a type of rhombus and a square is a type of rectangle, all right? And then down at the bottom, we've got this summary here. And so this is just a way for you to kind of organize your thoughts, because it's a lot of information with all these properties. Students find this to be challenging. So just keep your notes close by as you work through the homework, and reference them as you go here. But it just has a couple of quick tidbits here. It says that a rectangle, we know the diagonals are congruent, okay? And then we know that it's a type of parallelogram. And then for a rhombus, that's also a type of parallelogram. The diagonals are perpendicular. They create that 90-degree angle. We just saw that. And they bisect a pair of opposite angles. That means they cut those angles in half. We just saw that as well in the previous problem. All right. Thanks for watching.